guys, let's do a third potential difference and electric potential problem. The electrons in an old TV picture tube are accelerated through a potential difference of 2.4 times 10 to the 4 volts. A. Do the electrons move from a region of high potential to a region of low potential or vice versa? B. Calculate the change in the kinetic energy of one of the electrons. And C. Calculate the final speed of an electron when the initial speed is 0. So to get a handle of what's going on, draw a picture, just like I suggest for every problem. We've got a parallel plate system here. So here I've drawn my parallel plates, and essentially you've got an electron in between that's either going to go from positively charged plate to negative, so high potential to low potential, or low to high. Now ask yourself logically, an electron is negatively charged. Which way is it going to want to move? Well, if it's already moving to the right, it's not going to be moving in that direction for a negative charge. It's going to move in that direction for a positive charge. So therefore, the only answer that makes logical sense here is that it goes from low potential to high potential. Okay, so that's for part A. Now for part B, calculate the change in the kinetic energy of one electron. So if you saw back in video 159, we saw that the change in electric potential energy is equal to the change in kinetic, or given the other way, the change in kinetic is equal to the change in electric potential. Now, the only difference is, as one of these increases, the other decreases, so we have to put a minus sign in front. Okay, now the change in kinetic energy is equal to the minus change in electric potential. Electric potential is given by Q delta V. So at this point, we just plug in the charge of our electron, which is a minus 1.6 times 10 to the minus 19 coulombs. My potential difference is given as 2.4 times 10 to the 4 volts. You simply need to plug those in a calculator and crunch it out. So it turns out that the change in kinetic energy is 3.84 times 10 to the minus 15 joules. So there you have your solution for part B as well. And finally, part C, calculate the final speed of the electron if the initial speed is 0. Okay, so here's the beautiful thing. I already figured out the change in kinetic energy for part B, so all I have to do is find the final speed Vf. And I was just told that the initial speed is 0. I have the change in kinetic energy. I know that the expression for kinetic energy involves mass, so I just need to find the mass of the electron. This is usually something not given in the question, just like the charge of the electron or a proton. You have to look it up or memorize it. So the charge of an electron is 9.11 times 10 to the minus 31 kilograms. So this is going to be my strategy for the last part. The change in kinetic energy means the final kinetic energy minus the initial. Well, kinetic energy is given by 1/2 mv squared. So 1/2 mv final squared minus 1/2 mv initial squared. And the beautiful thing is, well, I know that the initial speed is 0. So Vi is 0, this whole thing goes to 0 because anything times 0 becomes 0. So delta Ek is equal to 1/2 mvf squared. I need to isolate for Vf. So I'm going to multiply both sides by 2, divide both sides by mass, and take the square root of the entire expression. So Vf is going to be equal to the square root of 2 delta Ek divided by mass. So at this point, I just need to plug in my values. So square root 2, my delta Ek I just found up here, 3.84 times 10 to the minus 15 joules, divided by mass of the electron, 9.11 times 10 to the minus 31 kilograms. So when you crunch those in your calculator, you are going to get a final speed of 9.2 times 10 to the 7 meters per second. And of course, a direction is not required because we're asked to find speed. This is approximate, by the way. So that's it for this video, guys. Please smash that like button so that I know what I'm doing makes sense to you guys. If you do have any questions, be sure to leave them in the comments section below. Otherwise, be sure to subscribe to Physics in the Flesh so you never miss a video from me. Stay tuned tomorrow at 12 noon for video 162, Potential Difference and Electric Potential 4. Alright guys, that's it for this video. I hope you enjoyed it. If you did, be sure to smash that like button so I know what I'm doing makes sense to you guys. And you know how you can stay tuned for my latest videos? By subscribing to Physics in the Flesh. I post every weekday at 12 noon, and this way you guys can always be the first to know when I post a new video. As always, guys, thank you so much for watching. If you missed any of my earlier videos, be sure to click over there on the right. You can click and watch those videos on your screen right now. Anyways, guys, physics in the flesh out. Whoop, whoop. Holy crap, my nose looks big on camera. I gotta find a new angle.